Good morning, dear students. Hope you all are ready for the class. Yesterday, I had spoken about Euclid's division lemma and algorithm. Today, I am going to discuss about fundamental theorem of arithmetic. Before we go to the topic, a few terms which we want to know. The prime numbers, we already have studied about it. The numbers that has exactly two factors. This 1 and the number itself. Composite numbers, the numbers that has more than two factors like 4, 6, 8, 9. Co-prime numbers, a pair of numbers that has only one as common factor. Means two numbers having one as common factors. Like 1, 2, common factor is 1. 2 and 3, common factor is 1. 3 and 4, common factor is 1. So they will be known as the co-prime numbers. Now let us come to fundamental theorem of arithmetic. In short, we write FTA. It says that every composite number can be expressed or factorized as a product of primes. And this is unique apart from the order in which they occur. Unique means whatever the way you write, but the prime factors which has occurred, it will be the same. Order may be different. Just see for an example. 6 can be written as 2 into 3 and 3 into 2. But what are the prime factors? 2 and 3 only. And like if we square 6, we get 36. We prime factorize, we are getting 2, 2, 3, 3. Or we can write this as 2, 3, 2, 3. Or we can write it as 2 square and 3 square. But in all cases we find the primes are what? 2 and 3 only. Now let us see the application part of the fundamental theorem of arithmetic. Question is, check whether 6 to the power n can end with digit 0 for any natural number n. Means if you are raising any power, you are taking n as any power 1, 2, 3, 4, 5. But always whether it ends with 0 or not, that we need to check. So what we will do first, we can write 6 to the power n as 3 into 2 to the power n, 3 to the power n, 2 to the power n. So here 2 and 3 occur in prime factorization, and this is unique according to fundamental theorem of arithmetic. So now for 6 to the power n to end with digit 0, there must be 2 and 5 in its prime factorization. Since 5 is not there, so it cannot end with the digit 0. Now let us take another example. Find LCM and SCF of 6 and 20 by prime factorization. We know 6 can be written as 2 into 3. 20 is equal to 2 into 2 into 5. That is 2 square into 5. What is SCF? So here the SCF, you should be very careful. SCF is what? Product of smallest power of each common prime numbers involved. Here it is very important, each common prime number. So in the prime factorization, first we will see what is common. So we find here 2 is common in both. And then what is the least power? Smallest power. So here 2 square, it is 2 to the power 1. So we will take 2 to the power 1. So SCF of these two numbers is what? 2. Now LCM. LCM is what? Product of greatest power of each prime factor. Each prime factor involved in the numbers. Means we will be taking into consideration all the prime factors and their greatest power. So again we observe. So what are the prime factors? 2 is there, 3 is there, 5 is there, but 2 has greatest power in 2 is what? Square. So we will not take 2, we will take 2 square. So 2 square into 3 into 5, that gives you 60. Again, note here that LCF of these two numbers and LCM of these, if we multiply these two, we are getting 120. And when we take the product of the numbers, this also gives you 120. So we can conclude that SCF of AB into LCM of AB will always be equal to A into B. So this particular relation, be very, it is important. Means when you have the three things given, like say for example A, B and LCM is given, we can find out SCF, or A, B and SCF is given, so we can find out the LCM. So out of these four, any three is given, you can find out the fourth one by using this relation. Now we'll go for the irrational number. So we have already discussed in the beginning only what is irrational number, the numbers which cannot be expressed in the p by q form, or the square roots of all those numbers which are not perfect square, or cube root of all those numbers which are not perfect cube. Now we'll see how to prove a number as an irrational. So the question is, prove that root 3 is an irrational number. So we'll assume the contrary. Let root 3 is a rational number. Then we can find two numbers p and q which are co-prime, and q is not equal to 0, means root 3 can be expressed in p by q form, where p and q are co-prime integers, means they do not have any factor. Even if they have factors, we will reduce it in the lowest form, and let us assume that p and q is in its lowest form and q is not equal to 0. So we'll simplify it. So we can write root 3q is equal to p, or squaring it, 3q square is equal to p square. Now one important theorem is there. Just understand here that if 3 is a prime and it divides the square of an integer, so here 3 is a prime, p is an integer, so it divides the square of an integer, so this 3 will also divide p. This is a theorem we can apply here. So 3 divides p square, 3 is a prime, so 3 divides p. Now if it divides, we can write this in this form. So let p is equal to 3c for some integer c. Means when we divide p by 3, we are getting an integer, and that integer is c. Squaring again, we are getting p square. So p square is 3c the whole square, and p square we can use 1 here. P square is 3q square. So we have written in place of p square as 3q square is equal to 9c square. So we find now q square is equal to 3c square. On the same lines, we can say 3 divides q square, 3 is a prime, so 3 divides q. Now 1 and 2 and 3, what we have found? That 3 divides p, 3 divides q, it means 3 divides both p and q. So we can say 2 and 3 implies p and q have common factor 3 other than 1, which contradicts the fact that p and q are co-prime as we have assumed. So thus the assumption that root 3 is rational not correct, hence root 3 is irrational. So all those questions which we need to prove as irrational, we can prove it in this very particular way. Now let us take another question. Prove that 3 plus 2 root 5 is irrational. It's very simple. So again on the same line, we'll assume it to be rational. So if it is rational, it can be written in p by q form. P and q integers, q is not equal to 0. We'll simplify it and we'll try to take root 5 on one side, remaining all on the other side. So first take transfer this 3 this side, so minus 3. So p, take LCM, so p minus 3q by q. So root 5 take to this side, so p minus 3q, here it is multiplying, so it will divide p minus 3q by 2p. What we observe that p minus 3q will be an integer, and since q is not equal to 0, so 2q is not equal to 0, so we are finding that integer by non-zero integer, so it is rational. But we know that root 5 is irrational, so it is irrational, it is rational, so this equality not possible, contradicting our assumption. Hence 3 plus 2 root 5 is irrational. So this is how we are going to prove irrational numbers in these two ways. You can have many questions in the book also, variety of questions are there, so you need to solve all those questions. In case of any problem, you can come back, and please comment that whether you have understood, whether you have not understood, or if you have problem in any specific question, please ask and I will make efforts to clarify your doubts. Thank you very much. Have a great day. Again, we'll have a class tomorrow in the same time, and utilize your time preciously because you are in class 10, and try to cope up with the syllabus. Thank you very much.